All right, so we're going to start off this video with the CPM 3V parts. I'm going to start with a few thoughts here. Looking at the modes of failure on this, I do believe, and I've maintained this for a long time, that the way to combat what I consider deficiencies in this older CPM material now is through a change in the chemistry. There was a patent and some testing done back in the day for an improved 3V, but unfortunately Crucible went through a bankruptcy, and I think that just got dropped and forgotten, and they rolled back to this known standard. It's a great steel, but we need to get away from this mythology status of this material. It's wonderful, but there are some shortcomings with the longitudinal toughness and some of the structure at a microscopic level of the steel, where we could get an improved refined grain structure and better performance and less toughness disparity between the longitudinal and transverse values. And we've milked everything that we can between Nathan and some of the different people around in the industry. We're pushing the limits of what this material is capable of, and it's to the point where it causes part warpage and extra handling and a bunch of just additional headache to try and get that result we're looking for. That's where I started looking over the pond at Böhler Uddeholm and saw the K890 grade, and they seem receptive to that, where after some conversations with the folks at Niagara and Crucible, I don't think that with any reasonable time frame we're going to see any real innovations or improvements to this formulation. We keep doubling down on things like S45VN and calling that an improvement, where that's marketing stuff. We're not breaking any new ground over S35VN and those little changes in composition. It creates a new number and a new marketing point to talk about, but we're not innovating. We're not trying anything new and novel in order to push the industry in a better direction. So I'm really glad that Böhler was receptive to what we were asking, and now we've got some of this to test and confirm. And I think that looking at that, this is always going to be relevant, but I think for the benchmark in toughness and edge holding, this formulation, at least a 3V, I believe its days are numbered, and I'm going to show you why. So starting right off with the lower hardness, this was an early Delta Protocol sample done by Nathan. We did have really good edge stability here, and I can tell with that heavier edge weight of our older models that where I want to go with our combat series here to ensure that they're absolutely failure proof. But you can see here we had just a couple of little flat spots along here, and that handled that amazingly for the type of abuse we put that through. So that's a great standard. And then we have a lighter edge weight on our production GS06 here. So chopping that giant nail, we did have a little bit of deformation in the panel, but again, it's a highly ductile material even at this high hardness. So it yielded, and we didn't really have much of the apex break there, but we started to have the panel yield a little bit off to the one side because I didn't hit that as square as I should have to not run into that shortcoming with the transverse toughness. Even with Nathan's latest protocol, I saw a video back in December, it's still an issue, and we're doing the best we can. This isn't a fault of Peter's heat treat or the Delta Protocol. We are milking everything out of this material. So please know that, and know that everybody, us smaller makers, we all were quality focused, and we've been pushing a long time for improvements to this, but it's just we don't have much push. And the larger selling outlets and entities, they don't have any incentive to push things. If what they're selling right now works and they can convince you that's the best, there's not much incentive to disrupt the money machine with innovating. So again, I'm really glad that Böhler was able to provide us a billet of this sample material. You won't see anything like 5.1s for quite a while. There's a lot of logistics with some of the tariffs and duties and things imposed on the thicker grades of steel across the pond. So we're going to have to figure out some logistics of how to get some of these materials across the pond in the thicker grades. Right now, we only have the two thicknesses to start off with, And we're pushing to make sure we can try and get these expanded as quickly as possible to start getting that alloy into some larger parts where I think they're really, really going to start shining in those applications where we're hitting things really hard. And I think we're entering a new era of high performance steels. So looking at the second sample here, this is a more recent Delta protocol here, down to 60.5. I think that apex stability was even better than that early sample here. We did have a little of the panel movement there, but this is a slicier, thinner geometry. Any type of practical use, this holds up wonderful. I want these to be a pleasure to use and have a really high durability standard, but you're balancing the overall failure point with the usability. And we've had a lot more positive feedback since we started thinning out some of our geometries, and now that we're getting into the EDC series and more efficient things. Generally, that's what users want. There are some fringe circumstances where we want something with a higher failure threshold, so a heavier duty tool overall, and I think the Vendetta series is going to fill that role. So looking at this here, again, sorry, I keep getting off task, but got a lot of thoughts right now. So that started to roll, but we still have decent apex stability there. And looking at the spine here compared to the high temper, high ductility standard, we had one little blowout here, but we have much more deformation on the spine. So putting all of this on balance, as well as the improved corrosion resistance from the low temper protocol here, I think for anything we haven't heat treated with already, we're going to move back to the Delta protocol. So now that we're back in PA, we have some pre-handling techniques that we've been talking about, and if this isn't the backbone of our production and we have other more reliable materials that we can use, I can spend the extra time needed to make sure we're holding the highest standards for these materials. And if they need some extra handling, that we can do that, and it's not breaking us and stopping all of our production. You know, we like to do the best job possible, but overhead's real. So we have to always be keeping things moving and getting units out the door, and I want to believe in everything that we're doing. So for the backbone of our production, we're picking things that are absolutely reliable. And then for some of these other materials where they're a little more fickle, we're just going to do that in smaller batches where we can absolutely control every aspect of it. So looking at this, the damage and everything is very similar to my high ductility standard, except that I can see we have a higher compressive strength looking at the damage on this spine. There was one little blowout, but once I had a chance to look at this high temper standard here, the high ductility, this is a great standard, but you can also see it's failing in similar amounts here at the panel. And just a little panel deviations because it's the same edge weight. And can I get that to focus? There we go. So again, we don't have much more rolling or anything at the apex, but when I looked at this, we're starting to get where this almost blew out across here. We've got some creases where I see we're right at the threshold of fracture and mushing out. So I think that was just a couple of pounds difference in me hitting that, where this has the higher compressive value, and I think this is going to functionally be the better option for everybody. So like I said, if we haven't heat treated it already to this standard, it's a wonderful standard, but now that we're back here and can have tighter control, looking at everything on balance, I think I'm just going to go back to the Delta protocol, and that's going to be our standard for our 3V offerings from now on. And we're just going to expand the amount of offerings we have so everybody has something they want, and we can serve everybody most appropriately based on their needs. So I was very happy with that as well. Just very little deviation down there in the low bevel, even cutting through that hard material. So yeah, definitely nice heat treat. Now, this last example broke my heart a little bit, but this is why I think 3V especially is very critical in how it's handled to get the most out of it. This was the Boise local heat treat, and they didn't do anything wrong. They just don't have the same equipment that Peter's heat treat has. It's a much smaller operation, so they're not able to quench as fast. The cryo is not quite as deep. So this failed much more spectacularly, and that was pretty disappointing, but that just reconfirms my thoughts on that, and where there are different bits of feedback and durability standards on 3V across the industry. It's not all the same, even if the hardness is the same. That's within a half point of not that one. I mean, this is softer, so obviously it took the damage a bit better, but due to the really fast quench and our different handling treatments, this is still a stiffer edge than this, even at a lesser hardness. But these are within a half point of the same. They're the same edge weight roughly, and they had a much different result. So that was disappointing, but it's not unexpected. So all 3V is not the same. Please keep that in mind when you're buying things. I should mention, this is also why I never made a Scandi in 3V. When you have a high chromium, high vanadium steel, it has a very high abrasion resistance, and with a Scandi style knife, you're grinding the whole daggone bevel that's huge in a Scandi. So if you have this sort of apex damage in these fringe circumstances, it's a bear to grind all that back on a large cutting edge like that. There's actually a lot of high quality stainless steels that would handle the side loading in a Scandi geometry a lot better than something like 3V. So other than a couple of knives I've made in the past, way back in 2012, 2013, for people that knew that what they were getting with the 3V knife, just for woodworking, things like that, it's phenomenal. But when you get into the side loading where you want to be doing heavy batoning, or you might be hitting something harder than wood, rope, leather, things like that, if you have a mixed use case with a Scandi, the apex is going to want to fold over just due to that toughness disparity between the longitudinal and transverse toughness. So when you look at those transverse values, there's actually a lot of stainless steels on the market that handle that side loading a heck of a lot better, and they're easier to resharpen than something like 3V. So aside from the steel and all the toughness claims and everything, you need to really understand what these materials are so that you're using them appropriately in each use case, and you're not setting your users up for failure or just a negative experience. So that's guided a lot of our decisions. And we've always known this about 3V, and we've been doing everything we can for years to optimize that and reduce that while we didn't have other options to 3V. But now that we do, you know, maybe we can push some innovation here on the US steel companies as well. But that's going to be up to a lot of you guys to demand that from them. So that's the 3V chapter. Next, we're going to move into the 5.1s here in Magna Cut. The damage here was more similar than I thought. We have differences in finish and out in the sunlight. This looked like it fared a bit better than it did, and so we're going to talk about this because these are about a half a point different in hardness, but they got there differently. We ran the Ostemp up here for the Boise company, and this is showing me that Magna Cut does respond really well to a variety of heat treats. It gets good hardenability across the board using various methods. So this is an interesting composition, but I'm also looking for greater uniformity in the materials within the material and batch to batch. So I'm hoping that as they're continuing to manufacture this, that they're taking notes and dialing it in, because there are some quality issues that are occurring that affect our ability to get this stuff out the door. There's extra warping and things sometimes if the material condition isn't quite perfect. That just causes us extra work again. And like I said, I want to keep using these materials, but we need to do it in a way that it's not the backbone of our production, because it's a little more unpredictable, especially with where we're trying to push these materials to get the most performance for you guys and girls. Me and several others of us out there, we just want you to have the best, and we really believe in what we're doing. And it's deeper than money. It's a passion, and it's a commitment to you guys. So looking at the Magna Cut, you can see here our standard is a little bit more ductile, which is where it put up with that dry bone and the frying pans and everything in the DBK video. But when we were hammering through the steel there, we did push the limit there and started to get some apex rolling. It didn't break the apex, interestingly, but we started to get some deflection in the panel there. And that's good because it's highly ductile, and rather than exploding, which stainless steels are known for, it started to yield. So that's going to be survivable. But then when I put this on balance with the spine condition, I can see we have a little higher ductility and less tendency to fail than this standard. I think we're very much pushing the edge of failure with this example. So rather than switching the formula around here, I know that we've been working on soak times and stuff up at Peter's Heat Treat, so I think this is just gonna work itself out for the most part to get us to what you're gonna see here on the apex stability while still being very ductile and able to take that abuse. So that's the panel overall, and you can see here how high, as I roll that back and forth, that crept up through the panel in that deflection. And then the difference in finish aside, it crept up the same amount here. Sorry, my hands are sweaty. So as I roll that back and forth, you can see that the deflection amount was the same height up the panel, but we did have greater apex stability there at the, I don't know if any of this video is going to be in focus, but I'm trying. We did have less apex breakage there, like where it didn't smush out quite as much. And I say that's due to the higher austenitizing temperature and just that little bit higher hardness. But as a result, looking at this side, we had several blowouts. That's not deformation, that's just missing material. So that just went away while I was batoning that, and it's somewhere out in the ground, out in the yard there. So I'm gonna stick with the more ductile standard. It's a little more failure proof, and it's an awesome daggone standard. And I do think with just some little soak times and stuff for hardening, change some of that around, I think we can optimize some of this out of here. So that did really, really well. There's much less disparity between the transverse and longitudinal toughness, and being higher in alloy, more fine grained. It has higher compressive values. So it put up with all of that abusive cutting very, very well. And I think that any well-made stainless is gonna have high compressive strength, where it's gonna resist deforming pretty daggone well, even up to its point of failure, where it's gonna fail more suddenly, where the lower alloy things tend to be more gummy and start yielding and deflecting as their mode of failure, rather than just outright breakage. So really impressed with that, especially with the type of work we did. Where'd that sample go? Next, real quick, I just want to look at 20 CV. I'm using this just as an example to talk about M390. We will do some more stainless testing here, but we did some abusive cutting here, and we didn't have any real failure until I pushed the envelope, and I knew what I was doing there. So that failure was totally expected, and I just really took my day out on the edge with a nail just to force a failure. But if you take your time and even working through a nail, this is a really good steel. And on the M390 side of the same composition, just a 3rd generation particle steel, really, really tightly controlled batches and a very homogeneous fine grained material. Austria is equivalent of the same thing. It's going to hold itself together, and with the very high compressive strength, it's going to hold its apex structure really well. So in your day-to-day chores, if you're just doing a lot of like box cutting, rope cutting, things where it's just abrasive wear rather than a bunch of shock, 20 CV or M390 well heat treated are going to be a great offering. This is a wonderful steel, so don't let the toughness values fool you. If you want to learn more, just go over to the abusive cutting video and you can see exactly what we did there. So next we're going to jump into the Elmax here. This is, like Ellie said, this is an 11-year-old formulation of Elmax with old handling practices, and it's only gotten better from here. But this really started to shine in that abusive cutting test due to it has a great balance of toughness and compressive strength with enough vanadium and stuff in there to provide really good wear resistance for good edge holding. So you can see it held up really well in the abusive cutting tasks here. We have very little damage. Other than the K890, I think this did the best. We have very little deviation in the apex there. This is completely functional after doing a lot of batoning through very hard materials. So we will be making a lot of small to medium knives in this. This is a wonderful steel if it's well heat treated. Like I said in the longer video, before I started Survive, I thought I hated Elmax, but It's just, I had gotten some knives made in it from some European brands, and it just wasn't heat treated that well. So it was just kind of mushy edged. It's just that high volume production standard heat treat. But once we started Survive, and I just hauled around, but I eventually got a sheet from Brad over there in Washington. And when we heat treated, I was really blown away with the performance. It did so well. So I'm very, very pleased to be offering this. It did withstand the smushing pretty well. We had a couple of blowouts similar to some of the other 3V blades. Just where we're exceeding its ability to absorb energy. And like I said, if you keep putting energy into something, it has to go somewhere. So it's either gonna go in the material that you're cutting, or it's going to break what you're hitting the knife with, or it's gonna start making the knife fail. So it's always intelligent. If you run into something that you're not through, don't just keep taking your day out on your tool. Just back up and reapproach and just look what might be happening before you have a failure. So that's, I mean, I can break anything. So what we're doing here is we're going to be offering things that are functionally amazing. And Elmax is just one of those things that is awesome. And I think in the 11 years since this batch of alloy was made, it's gotten way better. Böhler Uddeholm has made millions and millions and millions of dollars in investment in refining their processes and ensuring that they're making a really good product. They, up until recently, they haven't focused much on the knife industry. It's a lot of other aerospace stuff. It's a very large company, and knives aren't a big market in the overall steel market, but they're seeing the need for high quality materials in this market, and they are starting to respond, and that's so exciting. So save the best for last here with the K890 from Böhler. They all did pretty equally well. I think on this low temper sample, all of them just had a little bit of deviation in the panel, but very little apex deviation. So that is just because of the very, very thin geometry behind the edge, but no failure. It's very ductile at high hardness, 61, 62, even up to close to 64 Rockwell. When I'm putting all that energy in there, it's still wanting to yield rather than fail, and that's amazing. And then when I look at the edge stability of this, even in this we were just taking a stab at a low temper based on past experience, and damn, it did good. So we're gonna keep trying to optimize this. I'm gonna cut some blanks out for Nathan, I think, and send him some virgin material, and we'll start playing with that. That's gonna take a long time, so just forget about this for a minute, and if something comes of this, we'll all let you know, trust us. So next is our production standard for now. This is around 62 Rockwell, and you can see it's the same amount of deviation in the panel, but the whole cutting edge is still just about perfect. I've got one little roll there, but that would strop out. It's so minor. This whole cutting edge mostly still shaves, and the whole thing will still cut paper. So that's absolutely mind-blowing. And I can't believe today's real. So this is finally happening, and it's still sinking in for me that this has happened. So thanks to the folks at Böhler for helping us out there. I've been frustrated for a long time, but I can see we're headed toward better and better things here. And then finally, this is our little bit higher austenitizing temperature, where we landed at about 63.5, 64. And again, it's about the same panel deflection. It's harder to see because this is a more finished part. And again, no real apex damage. There's just nothing foily. That's some stuff sticking to the edge, but there's no major deviation. And then when I look at the spines of these things, the 3V parts, even the dome spine, there's some holes and stuff in it for me hitting it, but I can't feel anything on this spine. It's still perfect. So please let me know what you're thinking when you get these and you start using them. I think especially in the full flats, this is really going to shine as just a high performance steel where it's going to hold a really good edge and just perform really, really well overall. This is exactly what I've always been hoping for with heat treat optimizations with 3V. But you know, like I said, I did always believe the solution is a change in the composition so that the alloy matches the goals we're trying to achieve, rather than trying to make another material do something that it doesn't really want to do. The composition isn't appropriate in the older formulation of 3V to achieve these type of results consistently. So I'm glad we're able to, at least for our main production, able to move away from these really fringe handling circumstances where we're trying to get these overlapping values just right to produce the best result for you guys. It's always a moving target, especially if the condition of the materials is different from batch to batch, and it's just, there's little variables that just make it harder to work with stuff like that. So I hope all that was in focus enough to get some more information out of that and you weren't just sitting here listening to me talk. But yeah, really good testing. Overall, I think they all did really well for what each material is. And I hope that that gives you more information regarding these steels and the characteristics of these steels, just so you can make more informed decisions out in the market, but also to understand what the strengths and weaknesses of these different alloys are. Our next step for these, we're gonna remark these and set them outside for some extended weather testing and just see what happens to all of this over time. And we'll check in on it in a few months and then probably in about a year and just see where it all is, maybe tumble them, see what happened to the surface and what the weather resistance expectation is of all these materials at these different values. So anyway, that's it for now. I got to get back to work, but I hope you found this video to be enjoyable and informative, and stop back soon. We got lots going on and we can't wait to share it with you. Talk to you again soon.